Good morning, children. Today we are going to learn the continuous portion in that lesson 1, electrostatics. Unit 1, electrostatics. As like the previous days, you have to take one note, pen, pencil, rubber, everything and get ready for the classes. I hope you have learned the earlier classes well, I think. If you have doubt, you can ask to me. Okay. So last day what we have learned? Last day we have learned about the superposition principle and the distribution of continuous charges. About that electric field also we have learned yesterday. So today we are going to learn about the electric field lines. Electric field lines. What are these electric field lines? Yesterday we learned about two charges. One charge we have taken as source charge, another charge we have taken as test charge. So we know the first charge applying, creating some lines of force around it. So the test charge, from a particular distance it is detecting the source charge and experiencing the electric field from the source charge. Okay. So that about that electric field lines only we are going to learn today. These electric field lines are the visualized by the concept of electric field lines. This electric field vectors are visualized by the concept of electric field lines. They set up a particular visualized lines in some region of space. These lines are called as electric field lines. Okay. So, how to draw these electric field lines? What are the rules in these electric field lines that we are going to learn here? So, in the first, you see, yesterday itself we have learned there are two types of charges. Positive charges as well as negative charges. Okay. So, positive charges always acting outwards. Negative charges, the electric field is acting inwards. Okay. So, here what we are going to learn, the electric field lines are emanating from the positive charge and ending at the negative charge or at infinity. It is ending. Okay, that means the positive charge, from the positive charge the electric field is pointing outwards, radially outwards. From the negative charge the electric field lines are pointing inwards, radially inwards. Okay, this is the first rule. So, here in the second rule what it is saying, the electric field vectors are tangential to the electric field lines at that point. Okay. So, for that we can draw a diagram. This is a point here. How we can draw the electric field lines. This is positive charge. This is negative charge. Here Q plus Q, here minus Q. Okay. So it is electric field is a vector quantity. Why it is vector quantity? It has magnitude and direction. So it is a vector quantity. So this from this plus Q, you see here all the electric field lines are that they are pointing radially outwards. Okay. So here you see that in the negative charge it is pointing inwards. Okay. So this is the first second one. Okay. First one. That second. What is the second one? The electric field vectors are tangential. That also here only we are going to. You see, this is the electric field. The electric field lines, the vectors tangential to the electric field lines at that point. About a particular point we are going to learn. So you are going to learn about that particular point. That point is here. So the electric field vector tangential to the electric field lines. Okay, this is the second point. Next, the magnitude, the strength of the magnitude of strength. Okay, so that is depend upon the strength that where the magnetic lines of force are denser, the magnitude is more higher. Where the magnetic not magnetic electric. So where the electric lines of force are denser, that lines are more. So where the lines are more, the electric field lines are denser. So where the magnitude is lesser, the lines of electric fields of lines also electric field lines also lesser only. That is the next third one. Okay. So in the next point we can see no electric field lines intersect each other. Okay. If they are intersecting each other at a particular point, the directions, it will show different directions at the particular point. Okay. So what I am saying here, no electric field lines intersect each other. If at a point it is intersecting, the directions of the two, lines, they will be different. Okay. If at that point, at the particular point, the electric field lines are crossing, at that point if you are keeping any point charge, that point charge won't have to move in different directions. So it is physically impossible. What if it is impossible? Same charge cannot travel in two different directions. So it is impossible. So no two electric field lines cross each other. Okay. So in the last point, what it is saying, the number of electric field lines that is emanating from or coming out or originating from the positive charge and ending at the negative charge, that is directly proportional to the magnitude of the charges. That is directly proportional to the magnitude of the charges. Okay, these are the rules followed for this electric field lines. Okay, once more I am going to explain here. You see, what is the first, the electric field lines emanating from the positive charge and ending at the negative charge or ending at infinity. Okay, so the positive charge, the electric field lines which are coming from the positive charge, they are pointing radially outwards. Okay, the electric field lines here ending at the negative charge, they are pointing towards, radially towards the negative charge. The second point, what it is saying, the electric field vectors. The electric field vectors are tangential. What is tangential? Touching line. Okay, the tangential is touching line. The electric field lines are tangential to the electric field vectors. The electric field vectors are tangential to the electric field lines at that point. Okay, we are considering this point here. This is the second. Next, third one seeing time. the electric field lines are denser at the region where the number of electric field lines are more, higher. The electric field, the magnitude is then less denser where the electric field lines are low, some lower manner, so low. Okay, that is the next point. The next point, what it is saying, no two electric field lines intersect each other. If they are intersecting, the directions will be different. At the intersecting point, if we keep one point charge, what it will happen? If they will keep one point charge at that particular point, the point charge have to move in different direction. It is physically impossible. So, hence, no two electric field lines intersect each other. Okay. That so you know now what are electric field lines. The electric field vectors are visualized by the concept of electric field lines. They set up as continuous electric field lines and they are in the particular region of space. Okay, this is electric field lines. Then the rules also we have learned. Next we are going to learn about the electric dipole. Electric dipole. What is electric dipole? Two equal, and in this electric dipole also we are going to learn about the charges only, point charges. Two equal and opposite charges separated by a small distance that constitute electric dipole. I am writing the definition on the blackboard. And two equal and opposite charges separated by a small distance constitute an electric dipole. I have to know this. Okay. So what is electric dipole? Two equal and opposite charges separated by a small distance that constitute electric dipole. If you are considering a molecule, that molecules contains positive and negative charges. So whatever the elements, the positive charges and negative charges are not coinciding at a particular point, that molecules we can take, molecules can work as permanent dipole. Okay. So that permanent dipole, for example, the permanent dipole, CO, carbon monoxide, water molecules, carbon monoxide molecules, then ammonia, then HCl, hydrochloric acid. Okay, these are acting as permanent dipole. Okay, once more we can see the electric dipole. What is electric dipole? Two equal and opposite charges separated by a small distance. Yesterday also we are learning about the charges only. Here today also we know charges are positive charges and negative charges. That positive charges and negative charges, you see, two types of charges are there, positive charges and negative charges. So that only. But that magnitude also equal in this electric dipole. We have to consider two charges, both are at a particular distance. This one, if we are taking this minus q, this is plus q. Both are at a small distance. Both have same magnitude but opposite charge. Okay, same values and same magnitude and opposite charges. Charge only opposite, that equal, separated by a small distance. This distance we can take as A. from the center. Here A, here. Okay, this is electric dipole. For example, CO. So for this electric dipole have one electric dipole moment. Okay, all of you written this, I think. So I am rubbing. So what is electric dipole moment? Okay, so in this electric dipole moment, you can write as P vector. This is the symbol for electric dipole moment. Okay, so here in this electric dipole moment, what is electric dipole moment? The magnitude of the electric dipole moment is equal to the product of any one of the charges and the distance between them. That is electric dipole moment. Okay, so once more we can see about this electric dipole moment. P vector is equal to plus Q R minus Q R. Okay, so this is the formula for that. Here Q plus Q minus. Okay, the R is the R vector. Okay, R is called as R vector. So Q R. So this R, what is this R vector? R cap. This is what? This R cap is the unit vector. Okay, so this unit vector we can take as I told Q plus Q minus Q. So here the distance A. This is one is in positive x-axis and this is the center. You see the midpoint O. So this R we can write as AI. Okay. So P vector is equal to Q plus AI minus Q. This R vector for here minus, so here plus. So this here it is in the negative x-axis. So minus AI. Okay. So 2Q AI. EAI not at that time 1. So 2QA. Okay. Here this is the formula for the electric field moment of the electric field. Okay, so here 2QA. This we can write as inside this modulus. So P vector modulus P vector is equal to 2QA. This is the formula. What is the definition? The magnitude of the electric field moment. The magnitude of the electric dipole field moment, not dipole moment. The magnitude of the electric dipole moment is this one. The magnitude of the electric dipole moment is equal to the product of the these are the product of the magnitude of one of the charges 2Q and A is the distance between them. Okay, this is the formula for this electric dipole moment. Okay, next. The next we are going to learn about electric field due to electric dipole. Here two cases are there. One is the electric field at the axial line, then another one is in the equatorial line. Okay, so electric field due to electric dipole. Children, all of you listen. Here whatever I taught today, have you understood or not? You see, once more I am repeating it. First I taught about the electric field lines. They are the visualized. The electric field vectors are the visualized concept of electric field lines. Okay, they are set up continuous lines then they are in the region of space. They are visual representation, okay, of the electric field lines. Next, what are the rules we have followed for drawing that electric field lines? Okay. In the next case, we have learned about this electric dipole. What is electric dipole? Two equal and opposite charges separated by a small distance constitute electric dipole. For examples for electric dipole, or we are saying that particles as electric dipole we have learned. Okay, the electric dipole moment also we have learned. Okay, so now we are going to learn about the electric field due to electric dipole. Because of that electric dipole, the nearby points or point charges, how much amount of electric field they are experiencing, okay, because of this electric dipole. That only we are going to learn here. So first case, electric field due to electric dipole at points on the axial line. Electric field due to electric dipole at the points on the axial line. Axial line. Okay. What's the meaning of axial line? A line. Okay. So I am drawing here, you see. These two are the point charges, minus q plus q. Okay. This is the axial line. In this axial line, I am considering, or we want to locate a point C. This first charge, this minus q charge we have taken as A. The second charge we have taken as B. Okay. The point in that axial line we have to locate a particular point. That point I am saying as C. Okay. So this C point, because of this these two charges are there, both are equal charges. And they are separated by a small distance. This is the midpoint O. From this midpoint O, plus Q is at a distance A, minus Q is at a distance A. Okay. So, but this C is at a distance R. This C, the particular the point we located in the axial line. That point is at a distance R from the midpoint O. Okay. Now we here one electric field is acting there. Okay. Some electric field is acting. So that we can say as E vector. E vector is the electric field line. Electric field. That is a vector quantity. So we have written the vector notation. So electric field. Now we have to find out the electric field due to this electric dipole upon this point C. First, we have to find out the electric field experienced by this point C because of this point charge plus Q. Okay. So, we have to write the electric field at point C due to plus Q. I am writing this, rubbing this. I have written this heading, I think. So I am going to rub. Field at a point P, no, at a point C due to plus Q. Because of this plus Q charge, what is the electric field at C? Okay. So we know the formula for electric field. What is the formula for electric field? E vector is equal to, along with me, all of you write this derivation in your notes. Okay, you have no books, I think. So those who have books, look that. Those who not have books, you write this. Okay, so 1 by 4 pi epsilon 0 q divided by r square r cap. Okay, so here q divided by r square r cap will come. So this is our formula, but we have to write the distance. R is the distance from the distance from the point charge plus q to this c. Okay, so the total, what is the distance here? Totally r. So this r is from O to C r. This a we are subtracting, we can get this distance. And if you understood this, once more I am saying the total distance, I am drawing this here. The distance from O to C is r. Okay, O to plus q is a. So now we have to find out the distance between plus q to c. Okay, so for that what we have to do? Totally r minus this a. Okay, so r minus a the whole square. Okay, originally our formula is q divided by r square. So that r we cannot write here because that is from the center. We need the distance from the particular charge to the particular point. So that distance only we have to see here. So this is along BC. This is acting along BC. That is also we have to write. Okay. So here electric dipole moment we have to find out for this electric field. We know the electric field. So for this electric field we have to know, we know plus q and minus q. Two charges are there. They are acting towards BC. Okay. So we have to write the electric dipole moment vector. So what we have to write? E is equal to E vector. So this one E plus. E plus vector, because this one E plus vector, this electric field is due to this plus q. Okay, so equal to 1 by 4 pi epsilon 0 q divided by r minus a the whole square p cap. Okay, so here we have to write p cap, not p vector. Okay, p vector. This is also acting along BC only, BC. Okay. Next, the next case, the electric field at a point C due to this minus q. First, we have learned the electric field due to at a point C due to plus q. Now, the electric field at a point C due to minus q. In this place, plus q, we have to write minus q. Field at a point C due to minus q. Okay. Now that is E minus equal to 1 by 4 pi epsilon 0 q. Here this is negative, so minus we have to write here. So q divided by, we have found out this r minus a. How we have found out? Same thing. Here we see the distance between, here the minus q is some far away from that than this plus q. Okay. So from this midpoint O to C, small r is a value, then a some more have. So this one we have to add. So r plus a the whole square. Okay. This one O to C r, then O to minus q a. So this two we have to add. Then only we can find electric field the point C is experiencing because of the charge minus Q. Okay. So, R square. Then along, this is acting along AC. From A to C, this electric field is acting. Okay. For this also we have to find out the electric dipole moment. So minus 1 by 4 pi epsilon 0 Q divided by R plus A the whole square P vector. Okay. This is the formula. Sorry, here R vector, not R cap will come. R cap, this one unit vector, okay. Unit vector. Unit vector means magnitude also 1, direction also unit. So it is called as unit vector. So this is the unit vector in this electric dipole moment. Yes, in the previous classes we have learned about the unit vector in the displacement. Okay, here this is dipole moment. So 1 minus 1 by 4 pi epsilon 0 Q divided by R plus A the whole square. So listen, yesterday we have learned superposition principle. When we have used that superposition principle, if one point charge exerting some charge in another charge, we have used the Coulomb's law. But when we used superposition principle, one or more point charges acting upon a particular charge, at that time we need this superposition principle to find out the electric field. Okay. So here two charges acting at a point C. So here we have to use that superposition principle. Okay. I am writing here. So E total. So we have to write E total. Okay. So what is E total? E plus vector plus E minus vector. This electric field, this both are electric field only. This first electric field is because of the charge plus Q. Second electric field is because of the charge minus Q. Okay. So here we have to find out the vector sum. Okay. So we have to substitute this. So all of you written this, I think. Okay, I am writing here. 1 by 4 pi epsilon 0 E total is equal to, separately we have to write Q divided by R minus A the whole square P cap plus 1 by 4 pi epsilon 0 Q divided by R plus A the whole square P cap. Oh, no, here minus, because here minus is the sign. So we have to write minus here. Okay. And if you understood this. Okay. Now again I am going to evaluate that here. I am writing this. We have to solve that. What are the common terms there? All we have to take outside. So here we have to find out 1 by 4 pi epsilon 0. Here that is common. Then 2Q. Q also common. Q we have to take outside. Or first we have to take a common term outside. 1 by R minus A the whole square plus 1 by R plus A the whole square. Okay. Then P vector also common, that is unit vector, so we have taken the base. So here we have to solve Q divided by 4 pi epsilon 0. How can you are asked students, then other students also you can learn here. You see, here we have to take LCM. So how will you take LCM? So these two denominators we have to multiply r minus a the whole square into r plus a the whole square. Now cross multiply. This r plus a the whole square into 1. Then this r minus a the whole square into 1. So here we have to cross multiply and we have to write in the numerator and on the add. So r minus a the whole square plus r minus a, here r plus a, this one will come here. So r plus a the whole square. This term will go here. So r minus a the whole square. This plus we have to write up here the denominators we have to multiply and write. Okay. We have to write in the square bracket. You have to solve this, you know to solve, but I am solving here. You see, what is a plus b the whole square? A square plus b square plus 2ab. What is a minus b the whole square? A square minus 2ab plus b square. Okay, so first I am writing that formula identity, mass and mathematical identity. I am writing in the blackboard here. You see, a plus b the whole square is equal to a square plus 2ab plus b square. We are going to expand this in this form. A minus b the whole square is equal to a square minus 2ab plus b square. In this way we are going to change this. One more thing, you see here minus will come, not plus, because here minus, this minus we have to write here and here. Okay. Now r square plus 2ra plus a square minus r square plus 2ra minus a square. How it came? Here a square plus this term, but this minus will go inside. So all the terms it will change the sign in the second part. Plus come in place, minus come in place, plus. Here also plus will come because of this minus in the bracket outside. One minus is there, because of that minus it is this minus is plus is changing as minus. Okay, so divided by, here you see we won't expand this. If we are expanding this, it will become some conflict. So we have to write r minus a into r minus a, then r plus a into r plus a. Okay, we have to write this. Then p vector, p cap. Next we have to solve this. We can cancel r square cancel, then a square cancel. Okay, so what is the remaining terms? What are the remaining terms? Q divided by 4 pi epsilon 0. So 2 plus 2, 4 ra divided by, this one we can take, you see, r minus a into r plus a. Here another identity we are going to use here, mathematical identity. A minus b into a plus b is equal to a square minus b square. Okay, this identity we are going to use here. So this r minus a and r plus a, this r minus a and r plus a. So r minus a into r plus a, that is r square minus a square. Okay, next into r square minus a square. R minus a and r plus a, r square minus a square first r. Then p cap. Okay. Now we can also write this in your notes. Okay, take the note. Then any steps cannot understand, you can ask again. These steps you have to know clearly, otherwise you will collapse, confused. So I am writing here. Have you written this? I think. Then one more step will come. Q divided by 4 pi 4RA divided by, this we can write again, you see, these two are same terms. We can write R square minus A square, the whole square. So, R square minus A square, the whole square. Here, 1 P cap. This P cap we have to write. Okay, that is because of the electric dipole moment we are writing that. Okay, so Q by this. So, this is the total, E total vector because of this dipole. These two charges constituting a dipole. Why they are constituting a dipole? They are equal and opposite charges. They are at a small distance. So this one we know already the definition. According to that definition, these two are constituting a dipole. Because of this electric dipole, this point C experiencing an electric field. About that electric field only, that total electric field because of that plus Q charge and the minus Q charge. Okay, this is that. So you see here, this is the final. This equation we can take as equation number 1. This equation we can take as equation number 1. Then in the next case, you see, if this point charge, the point C we have located in that action line. So if this point is very far away from this electric dipole, these values will change. The A is very lesser. Lesser than R. R is very longer than this A. So at that condition, what will you do? How this equation we can modify. Okay. Have you written this or have you? So I am copying this. If it is very greater than R is very greater than this A, what will happen? What is the meaning of this? This point C is very far away from this electric dipole. So at that time, E total is equal to Q vector, Q divided by, here no vector, this is the shape. So 4 pi epsilon 0 4RA divided by R square the whole square. Because A we are neglecting because it is very smaller than this R. A is very smaller than this R. So we are neglecting that here. So R square the whole square. P vector will come. So Q divided by 4 pi epsilon 0 4RA divided by R power 4 P vector. So here this R and so what is the answer? Q divided by 4 pi epsilon 0. So 4A divided by RQ P cap. Okay. So here you see, we know what is electric dipole moment 2AQ P cap. Okay, this is the value of electric dipole moment. Okay, so that we have to write E total equal to this. We have to split this split into 2 into E. Okay, for your slow learners understanding, I am writing this. We all others know this 4 we can split into 2. So this 1 2 will come. So 2AQP cap, that is P vector. Instead of that much, see, we have to write this. So equal to 1 by 4 pi epsilon 0 2P vector divided by RQ. Here 1 2 is remaining. Thus 2P vector divided by RQ. This is the total electric. At that point C, when the point is far away. Okay, this is the next. And if you understood this, so this one we can use when we can use this formula. If the point C is far away from the electric dipole. If it is nearby, we cannot use this formula. We want to use this first formula only. This formula we can take as second, number 2. Well, if you understood this. So this is the electric field due to electric dipole on the ax, the point located in the axial line. Okay, this much all of you understood, I think. So again, in the next, now we have learned about this the point at the axial line. Next, the next is case 2. This is the case 1, axial line. The second case, the electric field due to electric dipole at a point located in the equatorial line. Okay, about that we are going to learn. You have to draw the diagram here, equatorial line. First I am drawing a diagram, then you can understand that. These are the charges, -2, -q, plus q. Okay. So here the plus q is some distance with the sides. The center point is here, midpoint O. So this is constituting electric dipole. Both the charges are equal and opposite charges constituting at a small distance constituting electric dipole. But the particular point we are locating at the equatorial line from the midpoint. This is point C. Okay. So in this point C we have to locate. This is angle theta, it is making angle theta. Okay, here on electric field, the electric field vector is minus P. Okay, so this is the point C. So this is electric field. This you see here, because of this equatorial line, this is equatorial line. In this equatorial line at a point C, what is the electric dipole experiencing due to minus q, then due to plus q at this point. Okay, so here because of this the electric field, it is this point experiencing two components. They are creating two components. One is parallel component, another one is perpendicular component. The perpendicular components are, two components are there for the perpendicular and two components are the parallel components. The perpendicular components are opposite to each other, so they are cancelled. That perpendicular components are E vector cos theta sin theta plus cos sin theta, E vector minus sin theta. These two are opposite to each other, equal and opposite, so they are cancelled. So that one we have no need to find out opposite each other and cancelling each other. But we have to find out the cos theta parallel components. Perpendicular components we cancelled and neglected. We have to find out the parallel components. While finding the parallel components, another diagram is also there. E plus sin theta, E minus sin theta vector. These are perpendicular components that are two equally opposite, so cancel. This is the resultant of the parallel component. This one plus E plus sin theta cos theta. This one E minus cos theta. Here E cos theta. Okay, this is the resultant for this. Okay, now. So here what we have to learn, here these two components are there. So E total taking time, E total is equal to E plus cos theta, here minus, so minus E plus cos theta, then minus E minus cos theta. Okay, these two we are taking as minus. Now, so E we know, E minus value and E plus value are same. So what is E plus value? 1 by 4 pi epsilon 0 Q divided by R square. This is the formula for this electric field. Okay, so electric field formula. In this electric field you see, this is the resultant. One more thing. You see, the distance from the midpoint to this plus Q is A, minus Q is A. The distance from the O to EC is R. Okay, that I left. So, now we know Pythagoras theorem. What is Pythagoras theorem saying? We have to find out this. So, the hypotenuse theorem, hypotenuse is equal to the hypotenuse square is equal to the adjacent side square plus opposite side square. So, R square, this R, then A. R square plus A square. R square plus A square. Okay. So, in this R square plus A square, we have to solve this. We have to substitute this in the previous formula. While substituting, we are getting minus 2 doubled. So 1 by 4 pi epsilon 0 we can take outside. So 2q divided by R square plus A square. Okay. So here 2q cos theta also. Here cos theta is there. So cos theta value, we know cos theta is equal to A divided by square root of R square plus A square. Okay. We have to write this R square. Here also 1 square is there. So next here this 2 we have to, this cos theta we have to substitute in this place. Substituting time we will get 1 by 4 pi epsilon 0 2q divided by R square plus A square the whole power 3 by 2. Okay. So here also in this equation that A value, if we are taking this C very far away, this R is very greater than A. A is the distance here. This A is very lesser than this R. At that time A we have to neglect. So the answer will come as 1 by 4 pi epsilon 0 2q divided by R cube. Okay. So this P cap is there. In the previous case, what we have learnt, 2a q is equal to P vector. So P cap is equal to. And the same thing we are going to 2a. Here A will come. Okay. So here also. So that A. So 1 by 4 pi epsilon 0 RQ. This is the formula for this equatorial line. The point at the equatorial line which is experiencing the electric field because of this electric dipole. Okay, all of you understood this. This is the derivation for the equatorial line. These two derivations you have to know well. So if you have doubt, you can ask to me. All of you noted these derivations, I think. So learn well. Yesterday's question also learned well. So today's question also. This, if you have doubt, you can ask to me. This A is from this formula cos theta. Cos theta value is A by square root of r square plus A square. Here we have to substitute and we have to solve that. Solving time r square plus A square 3 by 2 we are getting. We will get this answer at last. This is the final answer. Okay. So we can find out the value of electric dipole at a point from the due to this electric dipole. What's the electric field experiencing the point C at the axial line as well as in the equatorial line. Both we have learned. Both you want to learn well. This is very important. You write and see several times and learn well. Okay. Thank you children. Thank you.